Hi guys, welcome back to my channel S Chemistry. My name is Sonal, and in today's video I'm going to show you all how to deliver a demo when you're going for a teacher's interview or for an interview for the post of an assistant professor in the subject chemistry. So this video will be like a demonstration of a demo class. Okay, so with that being said, let's get started. A very good day to all. My name is Sonal, and today we are going to have a session on organometallic chemistry. So, before I start with the topic directly, can anyone over here try to give me the definition of organometallic chemistry, or perhaps what are organometallic compounds? Would anyone like to attempt this question? Okay, so let us start with the definition of organometallic chemistry. Okay, organometallic chemistry is a branch of chemistry, falls under majorly inorganic chemistry, okay, wherein we study organometallic compounds. Okay, now what are these organometallic compounds? Compounds which contain a carbon metal bond. Okay, compounds which contain a carbon metal bond are known as organometallic compounds, and these are studied under the branch of organometallic chemistry. Okay, now the definition is pretty simple. And let me tell you, you don't have to by heart this definition, okay? Because if you just look at the word organometallic, yeah, organometallic is basically made up of two words, right? Organo comes from organic, okay? And metallic is obviously metals, isn't it? Organometallic, right? Now, we know that in organic chemistry, the fundamental element is carbon, okay? So, carbon and metal. Fine. So compounds which contain a carbon metal bond are known as organometallic compounds. Okay. Let me give you an example. This example I'm sure you must have seen already somewhere in organic chemistry. Okay. That is nothing but a reagent which is known as Grignard's reagent. Right. Grignard reagent or Grignard's reagent. Fine, which we use in many organic reactions. Okay, what is the structure of Grignard reagent? RMgX, right? Suppose this R group is CH3. Okay, it can be any alkyl group. Let's just take it as CH3, methyl group. Okay, so CH3 MgX. Can you see a bond between carbon and metal over here? Yeah, there is a bond between carbon and magnesium. So this particular compound is an organometallic compound. Okay, but let me tell you one thing. This particular definition of organometallic compounds is not rigid. Okay, not rigid means that you cannot accept it universally. It is not universal. Yeah, can anyone think of a few examples, okay, which look or which appear to be organometallic compounds, but they are actually not organometallic compounds? Can you all have some guesses? Why did I say that this particular definition is not rigid or it is not foundational enough? Okay, so let me give you an example. Yeah, we have a compound sodium cyanide, right? NaCN. Okay, the structure of this particular compound is NaC triple bond N. Right, you can clearly see that there is a metal carbon bond in this particular compound, but I am telling you that it will not come under organometallic compounds. Okay, now why is this so? Why is this exception coming into picture? Okay, so let me tell you one thing in brief about organometallic compounds. We will study it later in detail, but for now let me tell you that majority of the organometallic compounds are involved in reactions wherein there will be a change in the oxidation state of the metal. Okay, so maybe you're starting with a +1 oxidation state, it can go to a +3 oxidation state. Okay, some change, either increase or decrease, but a change in the oxidation state of the metal. Okay, over here now, what is the issue? What is the issue with the oxidation state of sodium? Why sodium cannot really participate in such reactions wherein the oxidation state has to change. What is the reason? What is the reason? Yeah, sodium is a group 1 element, right? In sodium cyanide, it is already carrying a +1 oxidation state. Cyanide is a -1. Okay, so sodium is a group 1 element, and group 1 elements can only show a stable oxidation state of +1. It cannot go beyond that because at +1 it has already attained a noble gas electronic configuration, and that is why compounds like these, even though they have a metal carbon bond, but you cannot call them as organometallic compounds. Okay, so we are done with the definition. I gave you all an example, and we saw some exceptions, or some which are outside organometallic chemistry. Okay, now why do we have to study organometallic chemistry? What are its applications? Okay, can anyone give me an example of an organometallic compound which is present in our living system? Yeah, any compound which has a metal carbon bond, extremely essential for our biological system. What is it? What is it? Another example I can give you all. You all must have heard about this. Vitamin B12. Okay, vitamin B12 is essential in our system because it helps in production of red blood cells. Okay, now vitamin B12, it has a complex structure, but what is important for us is that it shows a metal carbon bond. Okay, the metal present is cobalt, transition metal, and there's a bond between cobalt and carbon. Okay, so this is an organometallic compound present in our system. Okay, other than that, some more applications. I showed you one Grignard reagent. Okay, so many of the organometallic compounds are used as reagents. Okay, they also play an important role in catalysis. For example, Wilkinson's catalyst. Yeah, Wilkinson's catalyst is used in hydrogenation reactions. Okay, so with that, I would like to conclude my session, which was targeted to introduce organometallic chemistry compounds to you all. If you all have any questions, you all can shoot them up right now. Thank you.